morning, everybody. So we're PRAM. So my name's Stephen McNulty. I'm the founder. We're commercializing 3D millimeter wave radars for climate risk monitoring. And I brought one to show you here today. So what's the challenge here? Well, effectively, the challenge here is that 15% of crashes on the network involve extreme weather. And 33% of geotechnical defects in structures are also weather-related. So let me just relay 2 points I picked up yesterday from the keynote speeches, maybe to back that up. So first, on the rail side, we had the chair of National Rail tell us yesterday morning that they're having 20-year earthwork failures now twice a week. And yesterday we had the Director of Highways and Transport from Cheshire County Council tell us that they had a bridge which failed, completely caused by extreme weather, causing her to have to go and find 3.3 million from her highway maintenance budget to try and deal with the issue. So this is the risk that we're trying to deal with. And from a climate perspective, we don't really know where it's going to happen, although we have some idea. We don't know when it's going to happen, and we have no idea how bad it's going to be. So that is the challenge that we are trying to deal with, and we're trying to provide a solution to with PRAM. So what are the kind of weather-driven hazards we mean? Well, direct hazards like road closures, cars stuck in floodwaters, and then indirect hazards like rutting or slope stability. So the beauty of a program like this is that I can wax lyrical about how fantastic this technology will be, about all these different things. But we had a great session last week where our partners said, whoa, 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 stop, stop, stop. Aquaplaning, icy roads, just focus there. We can't predict when it's going to happen. We can't predict where it's going to happen. And we don't know how bad it's going to be. If you can fix that, you have a real in, and that's what companies like us are desperate to get. So that is the value of a program like this, and it doesn't happen often. I've been on a number of them. So if a technology is going to solve this problem, what does it need to look like? Well, it needs to be ultra low cost. Sorry to the investors in the room, but that's true. So we have a target of this being £5 a week. It's got to be real time and predictive. We don't know where, we don't know when, we don't know how bad. You must have real time data. And that data allows you to predict the risk, and that allows you to deal with the hazard. It's got to be robust and sensitive. Sorry, sensitive is the right word. I'm a sensor person, so I guess my raison d'etre is I don't know what your problem is, but more sensors is certainly the answer. But in this case, that is what is required. This sensor is robust, as a radar sensor generally is, and it is sensitive, and it's highly versatile, as I'll show you in a second. And then we get very quickly into the integration question. Data cannot be siloed. So yesterday I had some fascinating conversation with a bunch of consultants, and always the conversation goes immediately to, yeah, but how do I use your information? So we've got to find a way to get that data into things like lane management systems and other risk management tools that are used by Tier 1 providers. We see that there's a gap in the market here at about 1% of the strategic road network. So where we think that there are drivers moving around, where we think there may be some historical evidence that there is risk, and where we think the road surface itself might be a cause of a problem. And that's what we're looking to find through this challenge. We imagine this as a full solution service, so hardware and software sold as a service. The benefits, well, if we deploy on 1% of the strategic road network at that kind of price point, it's about 1.7 million as a contract that we would receive. It costs about 2.5 million to prevent a fatality or deal with a fatality. Therefore, if we can avoid just one fatality, well, then our safety business case is pretty easy to make. In terms of market size and competitive alternatives, we see ourselves as in this road inspection system market, generally dominated by periodic maintenance and inspection vehicles. Some use of satellite data, some use of drone survey data. All the technology is great. I'm a technology person. But if it is in real time, it's not going to work for risks that are don't know where, don't know when, don't know how bad. So our business model is that we can, with one single device, we can roll out a multiple of features. So right now we're focusing on things like water level, water velocity, icy roads, standing water. But once that device is installed, we aim to deliver other features through that very same box. And although it's quite blasphemous to those in the room, perhaps even encroaching on the SVD type territory, because we can capture what cars are doing, just like we can capture what the weather is going to be doing. In terms of traction, so we've been around for about a year. We're spun out of another business that we have. We won a 4-year single-party framework council tender with Caerphilly County Council 2 months ago to roll this out at about 250 locations around the borough. We were funded initially by the Northern Ireland Department of Infrastructure, and we've been funded by Sellafield, and we're on-site in Sellafield deploying this technology, managing corrosion risk in our ventilation systems. We're also deep into a project with FDOT in the States through a connection I have in the US. We're waiting on the Environment Agency to launch a similar type of program to this. And through Sellafield, we've got into Dounreay, and then we're waiting on this massive EU tender to be awarded, I hope, in the next day or so. The team, so it's myself, a founder and CEO. James is our CTO. I guess what you've got here is a mix of folks who've built and scaled startups, technology expertise, and then people with deep sectoral knowledge about flooding and about disaster recovery. So again, just to leave you with the key point here, we're focusing specifically on climate hazards. Why? Because we don't know where it's going to happen, we don't know when it's going to happen, and we don't know how bad it's going to be. And that comes back to having real-time, low-cost data from a reliable and robust sensor, and that's what PRAM is. Thanks for your time.